In this video, we're going to focus on solving logarithmic equations with different bases. Now, the most important thing that you need to know for this video is the change of base formula. Let's say if you have log base a of b, this is equal to log b divided by log a, but with a different base. You can change it to any other base. We're going to call it c. C could be any number. It could be 2, 5, 8. As long as it's the same, the equation holds true. So that's the change of base formula. So let's say, for example, if I wish to evaluate log base 9 of 27, I can write it as log 27 divided by log 9. Now, what base do I want to use? Do I want to use 2, 4, 8, 3, 7? Out of all the numbers to pick, what number should I use? Now, what number goes into 9 and 27? The best number is 3. 9 and 27 are both divisible by 3. Now, what is log base 3 of 9? What is that equal to? How many 3's do you have to multiply to get to 9? 3 times 3 is 9. You have to multiply 2 3's. So log base 3 of 9 is 2, because 3 squared is 9. Now, how many 3's do you have to multiply to get to 27? 3 times 3 times 3 is 27. So you have to multiply 3 3's. So log base 3 of 27 is 3. And so log base 9 of 27, you can reduce it to 3 over 2. Now let's say if we have log base 3 of x minus 2, and let's say that's equal to log base 27 of 4x plus 7. Feel free to pause the video and work on this example. Solve for x. Now, in order to find the value of x, we need to make the bases the same. We have a base 3 and a base 27. So let's use the change of base formula. On the left, it's going to be log x minus 2 divided by log 3. Now, we'll choose the base later, but let's just write it out for now. On the right side, what we have is log 4x plus 7 divided by log 27. Now, we need to choose a number in which the bases will be the same, and we can reduce these two logs into a number. So what number goes into 3 and 27? The answer is 3. So every base, we're going to change it to base 3. So on top, we still have log base 3 x minus 2. And on the bottom, log base 3 of 3. Because they're the same, it's just going to be 1. 3 to the first power is 3. Now on the right side, it's going to remain log base 3 4x plus 7. And now what is log base 3 of 27? We've covered that already. We know 3 to the third power is 27, so it's equal to 3. So what we now have is this expression. Log base 3 of x minus 2 is equal to, if you divide it by 3, it's the same as multiplying it by 1/3. So we have 1/3 log base 3 4x plus 7. A property of logs allows us to move the constant in the front to the exponent position of the 4x plus 7 term. So now we're going to have log base 3 of x minus 2 is equal to log base 3 4x plus 7 raised to the 1/3. Now, because the bases are the same, since they're equal to each other, what's inside of the log expression, the x minus 2, must be equal to the stuff inside the other log expression. That is the 4x plus 7 with the 1/3 with it as well. So we could set the two things inside the yellow rectangles equal to each other. So if the bases are the same, the stuff on the inside must be the same. So x minus 2 is equal to 4x plus 7 raised to the 1/3. And somehow we got to solve for x. So let's raise both sides to the third power. 1/3 raised to the third power is 1. Whenever you have an exponent raised to another exponent, you need to multiply. 1/3 times 3, the 3's cancel and you get 1. So therefore we have x minus 2 raised to the third power is equal to 4x plus 7. So what should we do at this point in order to solve for x? Now we may need to FOIL the expression x minus 2. You can FOIL it 3 times, or you can use the binomial theorem to expand it. Now let's FOIL it 3 times first. Let's FOIL these two. So x times x is x squared. Negative 2 times x, and x times negative 2, that's negative 2x plus negative 2x, that's negative 4x. And finally, negative 2 times negative 2 is 4. Now let's multiply this binomial by this trinomial. X times x squared is x cubed. X times negative 4x, that's negative 4x squared. X times 4 is 4x. And then we have negative 2 times x squared, that's negative 2x squared. And then negative 2 times negative 4x, that's positive 8x. And negative 2 times negative 4, that's negative 8. And we still have the 4x plus 7 on the right side. So now let's combine like terms. So we have x cubed. We can combine these two. Negative 4 minus 2 is negative 6. And we're going to move everything from the right side to the left side. Notice that we can cancel the 4x's. If you subtract both sides by 4x, those two will disappear. So we have 8x left over. And let's take the 7, move it to this side. Negative 8 minus 7 is negative 15. So this is what we have. By the way, I'm just going to show you how to quickly use the binomial theorem, just in case you need to use it. So here's Pascal's triangle. 1, 1, 1. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 3 is 6. Hopefully you see a pattern by now. So use this row, the one with a 3, because we have an exponent of 3. So the first one is going to have a coefficient of 1, and then it's going to be x to the third power, negative 2 to the 0 power, plus use the second coefficient of 3, and then it's going to be x to the second power. This is going to decrease by 1. This is going to increase by 1. Negative 2, which comes from here, to the first power. And then use the next coefficient, 3. And then it's going to be x to the first power, negative 2 to the second power. And then the last coefficient, 1. And then x to the 0 power, negative 2 to the third power. Anything raised to the 0 power is 1. So the first one we get is x cubed. For the next one, this is going to be 3 times negative 2, which is negative 6, and then x squared. Now this is negative 2 squared is 4, times 3 is 12, so we get 12x. And then negative 2 to the third power is negative 8. X to the 0 is just 1, so that's negative 8. Now, right now it doesn't look the same, but keep in mind, this is the stuff on the left side. On the right side, we had the 4x plus 7. So 12x minus 4x will give you the 8x. And negative 8 minus the 7 will give you the negative 15. So if you understand the binomial theorem, it can help you to FOIL expressions that have large powers. Sometimes you might be able just to plug in numbers to see what works, and you can find the answer quicker that way. But we're actually going to solve it. So how can we factor this cubic polynomial. We can't factor by grouping. The first two terms do not have the same ratio as the last two terms. 1 and 6 doesn't correlate to 8 and 15. So we may have to use synthetic division. So first, let's find the possible zeros. The possible zeros are factors of 15. That's plus or minus 1, plus or minus 3, 5, and 15. So let's start with 1. Let's plug in 1 to see if it's going to equal 0. If it does, then we can factor it. So this is 1 minus 6 plus 8 minus 15. 1 minus 6 is negative 5. 8 minus 15 is negative 7, so that's not going to work. Chances are negative 1 is not going to work either. Let's try 2. So we have 2 to the third power minus, actually 2 is not a factor. Let's try 3. 3 to the third power. 2 is not a factor of 15, so that's why we can't use it. 3 to the third power is 27. 3 squared is 9. 8 times 3 is 24. 6 times 9 is 54. 24 minus 15 is 9. So we can see that this is not going to be 0. Let's try 5. 5 is a factor of 15. 5 to the third is 125. 5 squared is 25. 8 times 5 is 40. 6 times 25, 6 quarters is $1.50, so this is 150. 40 minus 15 is 25. 125 minus 150 is negative 25, so this adds up to 0. So 5 is a factor. So we're going to use synthetic division to simplify it. Let's write the coefficients of the polynomial that we have. I really didn't expect this problem to be so long, but since I've already went this far, I might as well finish it. Let's bring down the 1. Now we need to multiply. 5 times 1 is 5. Next, let's add. Negative 6 plus 5 is negative 1. And then multiply. 5 times negative 1 is negative 5. And then add. 8 plus negative 5 is 3. 5 times 3 is 15. If you have a graphing calculator, what you can do is you can type this in your graph calculator and find the x-intercepts. You can quickly identify the 5 that way. So this is going to be x squared, 1x squared minus 1x plus 3, which this quadratic expression is not factorable. So we can only use the solution x equals 5. So this expression here is equal to this quadratic expression times x minus 5, just in case you're wondering. But the answer is x is equal to 5. And now let's check it to make sure that it works. So here is the original expression. This is an equal sign. And let's replace x with 5. So we're going to have 5 minus 2. And on the right side, 4 times 5 plus 7. So 5 minus 2 is 3. And 4 times 5 is 20. 20 plus 7 is 27. Log base 3 of 3 is 1. Log base 27 of 27 is 1. So x equals 5 is indeed a solution. Let's try another problem. Let's try this one. Log base 8 of 16 plus log base 2 of x is equal to 10 over 3. So go ahead, pause the video, and try this problem. So let's convert everything into base 2. So log base 8 of 16 is log base 16 over log base 8. And so we're going to put a 2 in both of those bases. Now log base 2 of x, we're just going to leave it the way it is, because it already has the base 2, which we want. Now let's simplify this expression. How many 2's do we need to multiply to get to 16? 2 raised to the what power is 16? 2 to the 4th power is 16. You need to multiply 4 2's to get to 16. So the top part is 4. And you need to multiply 3 2's to get to 8. So log base 2 of 8 is 3. So we have 4/3 plus log base 2 of x is equal to 10 over 3. So now let's subtract both sides by 4 over 3. So these two will cancel. 10 over 3 minus 4 over 3 is 6 over 3. And 6 divided by 3 is 2. And now, to solve for x, we could change this logarithmic expression into its exponential form. So let me show you how to do that first. Let's say if you have the equation log base a of b equals c, then you can rewrite it this way. A raised to the c is equal to b. So let me give you another example. So we said that log base 2 of 16 is equal to 4. The reason for that is because 2 raised to the 4 is equal to 16. So now let's follow the pattern. So 2 raised to the second power is equal to what's inside, which is x. So x is 2 squared. 2 squared is 4. X is equal to 4. That's the answer. By the way, if you want more examples on logarithms, check out my video on logarithms review tutorial. You can search it out on YouTube. And if you have a difficulty finding it, just visit my channel and check out my algebra playlist. You should find it there. But let's continue. So let's try another one. Let's say if we have log base 2 x plus 3 plus log base 4 times, or of 5 minus x, and let's say that's equal to 3. So what can we do here? Now we can't use this rule yet. Log a plus log b is equal to log a times b. You can use this rule only if the bases are the same, which they're not. So we got to make the bases the same before we can condense the two logs into a single log. Now, we're going to leave the one on the left this way it is. We're not going to change it. We're going to change the 4 into a 2. Since the 4 is a larger number and 2 is divisible, or 2 goes into 4. So this is going to be log 5 minus x divided by log 4. And we're going to make the base a smaller number, base 2. Now, what is log base 2 of 4? Well, we know that 2 to the second power is 4. So log base 2 of 4 is 2. So now we have log base 2, x plus 3, plus log base 2, 5 minus x, divided by 2, which is the same as writing 1/2 in front of it. And all of that is equal to 3. Now, we can't combine it into a single log yet, because the coefficients are not the same. So therefore, we need to move the 1/2 to the exponent position. So we have log base 2, x plus 3, plus log base 2, 5 minus x, raised to the 1/2, and that's equal to 3. So now, we can combine it into a single log. To do that, we need to multiply these two terms. So we have log base 2, x plus 3, times 5 minus x, raised to the 1/2, and that's equal to 3. So now let's convert the log into its exponential form. So 2 raised to the third power is equal to everything inside. So that's x plus 3 times the square root of 5 minus x. And 2 to the third power is 8. So here's the difficult part, solving for x in an expression that looks like this. So first, let's get rid of the radical by squaring everything. 8 squared is 64, x plus 3 squared is just x plus 3 squared. And when you square a radical, it's going to disappear, so we're just going to have 5 minus x. So if you have access to a graphing calculator, the best way to find x is to type this in, minus 64. You want to have a 0 on one side of the equation, and then look for where the function touches the x axis, and that's going to be your solution. But let's do this by hand. So let's FOIL x plus 3 times x plus 3. X plus 3 times x plus 3 is x squared plus 6x plus 9. X squared times 5 is 5x squared. X squared times negative x is negative x cubed. And then we have 6x times 5, which is 30x. And then 6x times negative x, that's negative 6x squared. 9 times 5 is 45. And finally, 9 times negative x is negative 9x. All of this is equal to 64. Now let's move the 64 to the right side, and let's combine like terms. So we have negative x cubed. 5 minus 6 is negative 1. So we have negative x squared. 30x minus 9x is positive 21x. And 45 minus 64, I believe that's 19. But let me just double check. So this is negative 19. Now let's multiply both sides by negative 1. So this is x cubed plus x squared, and then minus 21x plus 19. So let's use synthetic division to solve for x. But we have to find the possible factors. Possible factors of 19 are 1 and 19. So chances are it's probably going to be 1. If we plug in 1, this is equal to 0. 1 plus 1 is 2. Negative 21 times 1 is negative 21. 2 minus 21 is negative 19. This adds up to 0. Now let's see if there's any other solutions. To find the other solutions, you need to use synthetic division. This might be the only solution, but we don't know. So let's put this number here, and the coefficients of this polynomial expression, let's write it on the board. So it's 1, 1, negative 21, and 19. So let's bring down to 1. So 1 times 1 is 1, and then add. 1 plus 1 is 2, and then multiply. 1 times 2 is 2. Negative 21 plus 2 is negative 19. Times 1, that's negative 19, which adds to 0. So this is x squared plus 2x minus 19. Two numbers that multiply to 19, that is negative 19, but add to 2, just is not possible. The only two numbers that multiply to 19 are 1 and 19. And these two, they don't differ by 2, they differ by 1. And they add up to 20. So this is not a factorable expression. So therefore, we'll stick with the first answer, x equals 1. Now let's make sure the answer is correct. So let's rewrite our original expression, which was log base 2x plus 3 plus log base 4, 5 minus x, and all of that was equal to 3. So now let's plug in 1. 1 plus 3 is 4, and 5 minus 1 is 4. Log base 2 of 4 is 2. 2 squared is 4. Log base 4 of 4, they cancel, you get 1. 2 plus 1 is 3. So this is indeed a solution. So this is going to be the last problem for today. So let's try it. Log base 9, 200x plus 129 minus log base 3, 3x equals 1. So let's use the change of base formula to convert 9 into base 3. So this is going to be log 200x plus 129 divided by log 9. And let's add a 3 to each base. So log base 3 of 9, what is that equal to? We know that 3 squared is 9. You need to multiply 2 3's to get to 9. So log base 3 of 9 is 2. So we can replace this with a 2. And we can replace the 2 with a 1/2 in the front. And we can then move the 1/2 to the exponent position. So this is equivalent to log base 3, 200x plus 129 raised to the 1/2 minus log base 3, 3x equals 1. So now that we have the same bases, we can combine the two log expressions into a single log. But notice that we have a subtraction sign. You need to know this property. Log A minus log B is log A divided by B. So let's go ahead and use that formula. So this is going to be log base 3 square root, because it's raised to the 1/2, square root 200x plus 129 divided by 3x. And all of that is equal to 1. Now let's convert it to its exponential form. So this is going to be 3 to the first power is equal to what's inside. So 3 to the first power is just 3. So to get rid of the square root, let's square both sides. Let's raise it to the second power. Three squared is 9, and the square root of something squared is just whatever that something is on the inside. 3x squared is going to be 9x squared. So this problem might be easier to deal with. Let's multiply both sides by 9x squared so that these two will cancel. 9 times 9x squared is 81x squared. So 81x squared is equal to 200x plus 129. The good thing about this problem is we don't have a cubic function. We have a quadratic function. So we can always use the quadratic formula to solve it. So this is 81x squared minus 200x minus 129. So you can try to factor this expression, or you can use the quadratic formula. Let's use the quadratic formula. It's x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So a is 81, b is negative 200, c is negative 129. So let's plug in what we have. So b is negative 200, b squared, negative 200 squared, which is negative 200 times negative 200. That's a positive 40,000. And then minus 4 times a, which is 81, times c, which is negative 129, divided by 2a. 2 times 81 is 162. So negative times negative 200 is positive 200. Negative 4 times 81 times negative 129. That's positive 41,796. So let's add those two numbers. If we add them, it's going to be 81,796. The square root of 81,796 is 286, which is a nice number. So this will give us two possible answers. 200 plus 286 divided by 162, and 200 minus 286 divided by 162. 200 plus 286 is 486, and if you divide it by 162, the entire thing is equal to 3. 200 minus 286 divided by 162 is equal to negative 43 over 81. So now let's rewrite the original expression. You need to be mindful of extraneous solutions. You can never have a negative number inside a log. It does not exist. If you type in log negative 5 in your calculator, you'll see a math error come up or something. So 3 is a positive number. If we plug it into 200x plus 129 or 3x, both results will be positive. If we plug this in into 3x, it's going to be negative. So this is an extraneous solution. So the answer is x is equal to 3. But now let's check it. Let's make sure that's the right answer. So let's plug in 3 into the equation. 200 times 3 is 600. 600 plus 129 is 729. Oh, by the way, this is supposed to be a 9. That was the original equation. So log base 9, 729 minus log base 3, and then 3 times 3 is 9. Let's see if this is equal to 1. So how many 9s do we have to multiply to get to 729? 9 times 9 is 81. 81 times 9 is 729. So we have to multiply 3 9s to get to 729. So that whole thing is 3. 3 squared is 9, so log base 3 of 9 is 2. 3 minus 2 is 1. So this indeed works out. So the answer is x is equal to 3.